Today we're going to look at potential divider and potentiometer. These are the answers for today's questions. Questions 1. A cell of EMF 2 volt and negligible internal resistance is connected in series to the two resistors of resistance 500 ohms and 1200 ohms respectively as shown in the diagram. A voltmeter is connected across the resistor at point A and B. What is the reading of the voltmeter if the voltmeter has infinite resistance? If the voltmeter has a resistance of 2000 ohm. So how to record the reading of voltmeter with infinite resistance? How does it affect our circuit? So as usual, I'm going to start from label the diagram. So this is the diagrams given. Now as you can see here, when you have a voltmeter with resistance, then this is the arrangement. You have an additional resistor that is being connected in parallel with the 1200 ohm resistor. So now let us label the diagram. I'm going to label the 1200 ohm resistor as R1, the 500 ohm resistor as R2, and the resistor inside the voltmeter as RV. And in this case, we have RV to infinite value. Calculate R equivalent. This is a diagram that we have right now. As you can see here, R1 and RV, they are arranged in parallel. So by applying the equations for R in parallel, we have 1 over R1V equals to 1 over R1 plus 1 over RV. And we have R1V as infinity in first questions. So as you can see here, when you use 1 divided by infinity, the value is equal to 0. Therefore, in this question, R1V is just equals to R1, which is 1200. And next, let us calculate the R equivalent R1V plus R2 because they are being connected in series. Substitute the values into the equations and you will obtain R equivalent equals to 1700 ohm. Once you have R equivalent, now let us proceed to step 3. Calculate I by using R equivalent and V. So V equals to IR, V equals to 2 volt, I times 1700. So I is equals to 1.18 times 10 to the power of negative 3 ampere. Step 4. Let us do a reversing process by calculating V1V using the I from previous step. So V1V is equals to IR1V. Substitute the values into the equations, you will obtain V1V equals to 1.41 volt. Now, since your resistor V and resistor 1, they are arranged in parallel, therefore VV and V1, they are also arranged in parallel. In this case, we say V1 is equals to V1V and it is equals to 1.41 volt. Questions B asks us to calculate the readings of the voltmeter, but now it comes with a resistance of 2000 ohm. So basically, you just repeat the same process as the previous questions and see what is the readings on the voltmeter. So again, let us start from labeling the diagram. So this is a diagram. And again, I have RV that is being connected in parallel with my R1. But now in this case, in this question, RV is equals to 2000 ohm. Step 2. Calculate R equivalent. So once again, if you look at the diagram, R1 and RV, they are arranged in parallel. Apply equations 1 over R1V equals to 1 over R1 plus 1 over RV. You will obtain R1V equals to 750 ohm. And then calculate R equivalent by using R1V plus R2. And you will obtain R equivalent equals to 1250 ohm. Then let us calculate I by using R equivalence and V again. So I in this question is now equals to 1.6 times 10 to the power of negative 3 ampere. It is slightly different than the previous questions. Step 4. Calculate V1V by using R1V and I. So V1V is now equals to 1.2 volt. And again, since RV and R1 they are arranged in parallel, therefore we say VV and V1 they are also arranged in parallel. And thus we have V1 equals to V1V equals to 1.2 volt. Questions 2. A potentiometer consists of a uniform wire AB of length 100 cm as shown in the following figure. A balance is found at a slider position 40 cm from point A when an unknown EMF, EMF1, is measured. When a cell of 1.5 volt is used, the balance point is now at 30 cm from point A. Determines the values of unknown EMF, EMF1. Since these questions involve the two EMF, therefore this is a case where we use potentiometer to compare two EMF. So by applying the equations for potentiometer, epsilon 1 over epsilon 2 equals to LAC over LAD, substitute the values into the equations and you will obtain epsilon 1 equals to 2 volt. That is the end of chapter 3 and that's all for today. I will see you all again tomorrow.